Biochemical conversion uses enzymes and microorganisms to convert biomass into sugars, and those sugars into biofuels or bioproducts that can replace products currently made from crude oil. Here's one example of a biochemical conversion process. After biomass is collected and transported to the processing facility, it undergoes a pretreatment process, so the components of the biomass are easier to break down with enzymes in the subsequent steps. Steam or water, sometimes in the presence of chemicals, is used to break down the biomass into cellulose, hemicellulose, and lignin. In one possible approach, acid is used for pretreatment. However, enzymes can't operate in highly acidic conditions, so a base is used to balance the pH, and the mixture is cooled before the enzymes are added. Enzymes perform a chemical reaction called hydrolysis. During this process, the enzymes break the cellulose chains into glucose and the hemicellulose chains into xylose. Glucose and xylose are the sugars that can most readily be fermented into ethanol or other biofuels. During the fermentation process, the mixture is inoculated with microbes, such as yeast or bacteria, that digest the sugars and secrete compounds that can be used as biofuels or biofuel components. This total conversion process takes approximately 3 to 5 days. In the case of ethanol, the liquid is separated by distillation, which is a method of separating mixtures based on differences in their boiling points. The resulting ethanol is collected and purified for use in blending with fuel. The sugars can also be fermented or chemically converted into longer chain molecules. With the addition of hydrogen, these molecules are processed into renewable gasoline and diesel. The solids and liquids remaining after distillation, known as stillage, then undergo a series of steps to remove water from the mixture. Solid and liquid separation, whether by centrifugation or other means, is used to recover the insoluble lignin-rich residue. This residue can then be sent to an on-site combustion system where it is burned to generate steam and electricity that can be used for power. The Department of Energy is working to develop cost-competitive advanced biofuels by reducing cost and improving efficiency throughout the biochemical process. Current R&D focuses on high-yield feedstocks, more efficient enzymes, and more robust microorganisms that will advance biochemical conversion processes to provide clean, renewable transportation fuels and other products.